Hey, what's going on, guys? Here we have a problem that is related to application of first order differential equation. Let's try to solve this one. So this question is asking if a battery supplies constant voltage of 40 voltage and if inductance is 2 henries and resistance is 10 ohm, given that I0 is equal to 0, find I of t and current after 0.1 second. Now let's go ahead and solve this one. First of all, if you look at this one, this is our generic pattern of first order linear differential equation, right? And also this is the equation that is related to circuit, and this is also a first order linear differential equation pattern. Now let's go ahead and plug the values in this equation and let's try to find the current, right? And L represents the henries, that is the inductance, right? This is our inductance, and that's provided, that is 2 henries, and also we have the resistance provided, that is 10 ohm, and here this E represents the voltage that is provided right here, that is 40 voltage, and we have all the information, so we can go ahead and plug it in this equation. So L is 2 henries, this is going to be 2 times di by dt plus resistance is 10, so 10 times I is equal to E of t. E of t is 40 voltage, so we are going to put that one right here. Let's try to simplify this one. We can divide everything by 2 in order to simplify this one, and if we divide, that's going to give us di by dt plus 5I is equal to 20. And this is the standard form of first order differential equation. And if you remember, to solve first order linear differential equation, we take the p of x value, and since we are dealing with respect to t, we have to take p of t. So p of t here is going to be equal to this 5, right? This 5, and then after we found out the p of t, we have to find the integrating factor. To find the integrating factor, we use this formula, that is mu of t is equal to e power integration of p of t dt. And we found out the p of t already, so we can go ahead and plug that one right here, and this is going to be e power integration of 5 dt. 5 is a constant, so it's not going to do anything, and integration of dt is going to be just t. So the integrating factor is going to be e power 5t. After we find out the integrating factor, we have to multiply this first order linear differential equation both side by this integrating factor. So we are going to multiply both side by e power 5t. After you multiply, you will get d, and I'm going to separate this d by dt alone. There's a reason behind it, you see. So d over dt and I e power 5t is going to be equal to 20 e power 5t. And if you notice, I left this other part alone, because in linear first order differential equation, after you multiply this one by the integrating factor, the first value, if you take that one alone, that's going to be equivalent to the whole thing. If you are doubt about this, you can find the derivative of this one and you will get this one back. So that's why the integrating factor is really helpful, because that will make everything easier, right? Now after we find out this one, and we know that this is equal to this one, therefore this must be equal to the other side, and we got the other side, and now we have to integrate both sides of this equation. Now let's do the integration. We are going to integrate this one respect to t, so this is going to be integration respect to dt, so dt, and if we integrate this side, here we have integration and derivative, it will cancel each other, and we are going to end up with I e power 5t, and in the other side of the equation 20 is a constant, so it's not going to do anything, and e power 5t, we have it's going to remain the same, but we have to divide this one by the derivative on top. So derivative of 5t is going to be 5, so we have to divide this one by 5, and also we have to add a constant. Now we are almost there. Let's simplify this one. I times e power 5t is equal to 4 e power 5t plus constant. Now if you notice, we have e power 5t both sides, so we can, to simplify this one, we can divide everything by e power 5t, and if you divide, you will get I is equal to 4 plus c e power negative 5t, because when we divide, these two cancels, c over e power 5t, and if we bring this one to top, that's going to be e power negative 5t. And this is the general solution for this differential equation. Now to find the particular solution for this differential equation, what we can do is, since they have provided this information, I of 0 is equal to 0, we can put that one right here. I of 0 is equal to 0, and therefore 0 is equal to, and the time is 0, and e power 0 is going to be just 1. So 0 is equal to 4 plus c times e power 0. This is 1, so c is going to be equal to negative 4. So the particular solution for this differential equation is going to be I is equal to 4 plus, actually 4 minus 4 e power negative 5t. Now let's go ahead and write this one right here. I should get rid of this part right here because I need some space. Okay, let's get rid of this one and continue this one right here. So I'm going to copy this thing. I is equal to 4, and we found out the c value, that is negative 4. So we are going to plug that one right here. 4 minus 4 e power minus 5t, and this is the particular solution for this differential equation. And this one, you can simplify this one furthermore, like you can take the 4 common. If you take the 4 common, this is going to be 1 minus 1 e power minus 5t. Also, we don't need the 1 after this. We can just leave it like 1 minus e power minus 5t, and that's going to be the particular solution. Also, here they have asked to find the current after 0.1 second. Now to find the current, all we have to do is just plug the t value. So I of 0.1 is going to be equal to 4 times 1 minus e power minus 5 times 0.1, and if you calculate this one, you should get 1.57 ampere, and that's going to be the final answer for this question. I hope this is helpful. Thanks for watching.